Important note is it says the diagram is not accurately drawn. So that does mean that you can't measure anything. You can't use your protractor to measure angles. You can't just measure the sides and hope to get it right. We've got to use the ratios. Okay, so we're going to look at this triangle, right? And what we need to do is we need to look at what information I have and therefore what I can use to work something out. Right? So we are told it's a right angle triangle. That's important because obviously if it wasn't a right angle triangle, we couldn't do this. Right? So we're being told that in a couple of ways. We've got that it is a been told it is a right angle triangle. And we can see here it's a right angle triangle as well. Now that's important. Now we're being told that angle B is 90 degrees. Yeah, we've got that angle A is 36 degrees. We've got that there. We have been told that the length between A and B, is 8.7 centimetres. All right. And we're being asked to find out the length of BC. So BC is this length. This is what I'm going to be asked to find. I'm going to call it X just because it's an unknown. All right? Make sense? Yeah. So I've just analysed the question. What is the information given and what do I want to know? Now the first step is to say, well, which sides are which? So, if you like, yeah, go.
So the one on the top is the adjacent.
So this side is the adjacent side. This side?
Yeah, that one is the hypotenuse.
This one is, you're correct, the hypotenuse.
And then the last one is the opposite.
And this one is the opposite side. So we've identified those. That's all important. So maybe you want to write that on your diagram now, whether you want to write the whole words or just the O, the A, and the H. Okay? All right. So, what we've got to try and remember now is the ratios and pick the ratio that we need to use. So, for instance, I know that I want to know the opposite side, okay? The opposite side is the one I want to find out. And the information that I know is I know the angle and I know the adjacent. So what I tend to do, and you don't have to, but this is what I tend to do, I write a little list and I say, do I know the angle? Yes, I do. It's 36 degrees. Do I know the opposite side? No, but I want to know it. Do I know the adjacent side? Yes, I do. Do I know the hypotenuse? No, I don't. Do I want to know it? No, I don't. So I cross out my little hypotenuse. So that's the information I've got, and I've worked out what I want to know. Does that make sense? Okay. The next thing I do is I need to try and figure out which one of the ratios do I need to use to help me solve the information that I've got. Because that's what I'm going to be looking at doing. Does anyone know which one they would use? Maisha? Opposite over adjacent. Yeah, because? Yeah, because we're trying to find the opposite and I know the adjacent. Now, one little tip I've got for you is, if we think back to here, look, where it says sine is opposite hypotenuse, cosine is adjacent hypotenuse, tan is opposite adjacent. I could do with a way of remembering those things. And the way that I do it is I remember, and you've probably heard this, people remember Sohcahtoa. Or they sometimes try and remember a rhyme, like some old hags came and had tea one afternoon, or they come up with something to remember. But I remember Sohcahtoa because, I don't know, it just resonates with a volcano that I knew about, Krakatoa. Just, anyone heard of the volcano in Italy that exploded years and years ago. Krakatoa. That's how I remember it. So Sohcahtoa. So I remember Sohcahtoa. You'll hear people say Sohcahtoa. When they talk about trigonometry, they go, oh, Sohcahtoa. Okay? So I write that down. And that basically means sine equals opposite over hypotenuse. So some people write it like this. Sohcahtoa to help them remember. Okay? So what we're saying is sine of the angle equals opposite over hypotenuse and so on. So you don't have to write this out for every question. I just write my Sohcahtoa to remember. And then what I do is I say, look, the one that I don't know and don't want to know is the h. So if I look at Sohcahtoa, I can cross out any that have a h in it. And that leaves me with the one that I have to use. So I can then write out that ratio and I go, oh, tan of the angle equals opposite over adjacent. And then I put the information in and I say, right, so tan of 36, which is, as we discussed, just a number, any number. In this case, it's tan of 36, so it'll be a specific number, which my calculator will tell me. Well, that equals x divided by 8.7. So there's a little bit of rearranging to be done. A little bit of rearranging to be done to figure out what x is. Anyone know how to do that? Just going back to your kind of algebra stuff. No ideas? Does that make sense so far where I'm at the moment? Got any questions on where it's come from? So I've used the ratio, I've identified the ratio that I want to use. And the reason why I've used tan is because of the information I've got and the information I want to know. So the other two are not useful for me in this case. Yeah? Well, what's the opposite side? And what did I call it? X. And what's the A, the adjacent side? So this is opposite, this is adjacent, okay? Guessing it? Very close, very close. However, remember it's not 36. What's the number on the left-hand side? It's not 36 degrees, actually. It's tan of 36. On your calculator, what is tan of 36 degrees?
0.7265422.
Okay, so 4, we can count. That equals, maybe you've got it in radians. Or maybe he's got his in radians. No, yours is in degrees. Hard to see. Yeah, I think it should be. Does everyone agree? Have you done it? Do you get that number? Yeah. Okay, does that make it any more sense? How do I find x? It will do if we change it. What do I do now, Nick? Yeah, so if I times by 8.7, that gets rid of my divide by 8.7. So I have to do the same. Now, just a little hint here. It makes sense to do tan 36 first. However, what do we do to this number now before I times it by 8.7? To write it down, I had to do what? Well, it's not simplify, it's rounding, isn't it? I've rounded it. And what happens if you round a number? You make it less... Not less complicated, less exact or less accurate. So what have I done to my final answer? Made it less accurate. So what you can actually do on your calculator, so on the calc, you're actually going to type in 8.7 times tan, and then it will have brackets 36, and that will give you x. And then you only have to round at the end to 3 significant figures. Okay? So on your calculator, you're going to type in 8.7 times tan 36, close the brackets, press equals, and what do we get for our length? So to 3 significant figures, 6.32. All right. Now, one thing we should do is we should just have a final check and just check, is 6.32 reasonable for this triangle? So if I put it up here, 6.32, does that make sense? And the only other thing I've got here is an 8.7. Does 6.32 kind of go with 8.7 as a size?
Yes.
Yeah. If I had something like 158, it'd make me check my working. Yeah.
Why does the 8.7 have to be? Oh.
So one little thing here is to mention, before I let you do the next one, 8.7 times, why didn't I do tan 36 times 8.7? Why didn't I write it down? Any ideas? Well, the truth is, it doesn't matter as long as you stick your brackets around the 36, so I know it's tan of 36. But so if I do that first and then do times 8.7, it's absolutely fine. But if I were to do tan of 36 times 8.7, you get a different answer. Okay? So that's fine. This would be wrong. So the reason is I put the 8.7 first just so that that doesn't become an issue ever. So I always do the number then times the tan, because you can see that 0.725 is tan of 36. They're the same thing. I can't change that. It's just a number. Yeah, Maisha?
It's the next one like that one, but like just a different sign.
Okay, yeah, so if we go to the next question, yeah, you've now got the same problem, different angle, and you're told different sides. So you need to identify the ratio for that one. So have a go at that one yourself. First thing to do is do what? Identify the... Okay, so this side is the... Okay, so that side's the opposite. This side is the... This side is the...
Adjacent.
So if I write down, do I know my angle?
Yep. Yes, we do.
Do I know my opposite side?
Yes. Oh, I get this. Okay.
Do I do my adjacent side?
No.
Do I want to know it?
Yes.
No.
No.
X is the opposite. So actually that one, my hypotenuse is 32. So do you remember I said I then write, I do my Sohcahtoa, because this is how I choose. This is how I choose the correct one. So, which ones do I cross out?
The T-O-A.
Anything with an...
H.
Toa and Ka.
No, not anything with a H, anything with an A. So, cross that one, cross that one. This is the one I want. So I'm going to use sine theta equals opposite divided by hypotenuse. Maisha?
How do you know which side is this?
Because of the methods. It's like, remember you were saying, you wrote it down in the book. Like, Gauss is always opposite of the reason or something like
I
that.
don't get what you're talking
Hypotenuse is the longest line.
So, do you remember that? We talked about it. The hypotenuse is the longest side.
Or opposite from the right angle.
Yeah, or opposite. So so this side, I immediately know that side's the hypotenuse. Because it's opposite the right angle and it's the longest side. Then I think what Thomas's idea was that if you look at the angle and you look at where it points to the opposite side. My way was to say the other line that makes the angle with the hypotenuse is the adjacent side. So whichever one you remember, that leaves the other one. Okay? Are you still on this one or next one? Well, there's plenty of people, yeah. If you've moved on, you'll have to wait a sec. So now the question is, what do we do now? Well, we've got this, so we write it out with the numbers. So we say sine of 60 equals...
equals x over 32.
Great, x over 32. So actually, remember we should say not over but divide, because that helps us work it out. I'm just going to go on. So what do we do? Can everyone look at this before Owen tells us the answer? Can everyone look? Do you all know what you would do at this stage? So I've got x divided by 32 equals sine of 60. So Owen, what do we do?
To isolate the variable, you have to times by 32.
Yeah, exactly. So at the moment, if you look at it, I've got x divided by 32. I want just x. So to get x back, if I divide it by 32, I have to times it by 32. That gets rid of the divide and leaves me with just x. But on the other side, I have to do the same thing to maintain the equals. So I've got 32 times sine of 60. Remember, I only put it that side just so it doesn't get mixed up with the 60. And now we just have to do it on a calculator. So remember, 3 significant figures, so it's 27 point... So it would be 27.7. Are there any units? Centimetres. Does it make sense? Yeah, because this is 32, so to have that as 27.7 makes sense. Okay. The next one should be fine. Do you remember back here, I posed a question and said, if I know what the ratio is there any way of finding the angle? All right. So what we've been doing up to now is identifying the sides if I know the angle. But what if I don't know the angle, but I do know the ratio? Is there any way of identifying the angle from the ratio? Now there ought to be, right? Because if I know the ratio, I should be able to say, well, that goes with that angle, because it is no angles in the triangle have the same ratio. And that's when we have this next question. Okay? What time? 10 past. This final question. Again, let's go through it. Sorry, 3. It's this one. Hold on. Okay? Question 4. So for this one, what is the thing that we're being asked to find? X, the angle, right? So I'm going to do exactly the same thing again. I'm going to write out that I've got to choose the correct ratio. That's always there. I'm going to find, do I know theta? Well, that's my x this time. My opposite side is 5. My adjacent side is... So I know that's my adjacent side because there's the angle. This is the opposite side. This is the... Now, do I know my hypotenuse?
No.
Do I need to know it?
No.
Daniel, are you focusing?
Yes.
Okay. I'm going to cross out my h then. So which ratio am I going to use? Nothing with a h in. So I know I'm going to use tan theta equals opposite over adjacent. So when I put that in, I've got tan of x equals 5 over 12.5. Now, So I've done everything the same up to this point, but instead of having to multiply by something to leave x on its own, now I've got tan of x. Now tan of x is a number, and I ought to be able to use that number to find the angle. And the only way to do this is to use our calculator. Okay? So the button that you are going to use looks like this. If I want to find x, I use the ratio, but what I do is I do what's called the inverse tan of 5 divided by 12.5, the ratio. So instead of using the ratio to find tan of x, I'm doing what's called the inverse tan. Now you'll hopefully notice that on your calculator, you'll have a tan button, and above it will be the tan to the -1. And you have to press your shift button or something to get it. Okay? Or your second function, or whatever it's called. Some calculators it's second function, some calculators it's shift. So what you do, on your calculator, you press your inverse tan. It will come up on your screen as inverse tan bracket. You can then do 5 divided by 12.5 and press equals. And we do it to 1 decimal place, so it's 21. So is it 21.8, is it? Okay, so we do our inverse tan. So can you make sure you can do that one now? We rely on our calculator for it. At this stage, I will never give you a question where you're not using your calculator. My M5s, however, are about to learn to do ones without the calculator. Does everyone get that? How to find it?